All right, this is 6-3, and the first part says to state the number of triangles possible with the given measurements, and angle A is acute, it's 29 degrees, so we need to be on the acute side of our note card, which means you have to find the height. So the height is B sine A, it gives you height, and side B is 18, so we're doing 18 times the sine of angle A, which is 29. So you do 18 sine 29, and you get 8.7. So your height is 8.7. And then we have to compare side A with our height. So side A is 17, our height is 8.7. This is A, this is B sine A. And we look at our little chart to tell us where we need to be. So angle or side A is greater than our height, so we are here. Okay, so if side A is greater than our height, then we need to compare side A and side B. So if side A is 17, side B is 18. Okay, so this is A, this is B. A is less than B, so there are two triangles. So two triangles. That's it. We're going to continue to use that today. It says we're going to be sketching. I'm not really going to make you sketch too many triangles, but we're going to find the missing angle B. So if there are two possible triangles, then there are going to be two possible angle B's. That's basically it. If there's only one triangle, then there's only one angle B. If there's no triangle, you don't have to find an angle B at all because there's no triangle to begin with. So that's the basis of it. It might look more complicated than that as we go, but that's really not it at all. Just find how many triangles. If there's one, then find one angle. If there's two, then find two. That's it. So, following measurements to determine the number of possible triangles. So it's acute again. So I did a ton of it already, so that we don't have to sit here and muscle through it. But so angle A is acute, so we're going to do B times the sine of A. So 16 times the sine of 50 is 12.6. So then we compare side A, which is 13, to our height, or 12.26. So 13 is greater than 12.26, so we have A is greater than B. And then we need to compare side A and side B because we are doing that again. So A is less than B, so we're at two triangles. Okay, so it's just like the warm-up was. We found the height, we compared side A to the height and found that it was bigger, so we had to compare A and B. It was less than B, so there are two triangles. Okay, so that's all the same thing we just did. So if there are two possible triangles and we are trying to find angle B, which we will eventually, then there are two possible angle B's. Our triangles could look like this, okay? When I made this, I actually made side A and side B and angle A all the same, and I just pulled side A over. So there, it's very possible, like you can actually make these and have two different triangles. But if that's the case, angle B is down here, okay, because side B is up there. So here's angle B, and here's angle B. So there are two possible angle B's. If you notice, the first one, it is obtuse, and the second one, it is acute. So there is going to be one angle B that is less than 90 and one angle B that is greater than 90, and they're actually going to be they're going to be supplementary. They're going to add up to 180, so we can find one and then find the other one by subtracting it from 180. So if you know two sides, if you know two sides in a non-included angle, we're going to use the law of sines because we're going to have side A and angle A. So we're going to have that complete set, so we can use the law of sines. Okay? So the first thing you need to do is know how many triangles are possible. 0, 1, or 2. And then you don't have to sketch it, so don't worry about this. But just know what that looks like. And then you're going to set up your proportions for the law of sines to find the angle. And then we're going to solve these to the nearest minute. We're going to go back to the nearest minute for a little bit. If there are two possible triangles, this is the important part, then you take 180 and subtract theta to find your second one. Okay? So you're going to get the same angle no matter what when you use the law of sines originally. But if there are two triangles, you just have to take it one more step and take 180 and subtract your angle to find the second angle. So This is the one we just did up at the top. So we knew that there were two triangles. Okay, so we're going to set up our law of sines. So we have the sine of angle A, which is 50, over side A, which is 13, and it equals, we do not know angle B, so it equals the sine of angle B over side B, which is 16. Okay, just setting up the law of sines, which I did down here. Okay, now we are going to cross multiply. That's how we use our law of sines. Cross multiply. So we have 16 times the sine of 50 equals 13 times the sine of B. Okay, so 16 sine 50 gives us 12.25 blah 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 equals 13 times the sine of B. So then we divide by 13, which is going to give you the sine of your angle. You don't have to write all this down, but this is, so the sine is 0.94 blah 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 blah. So then you have to second sign your answer. So second sign, second answer, and you get 70.53. Okay, so there's our first angle. We know that there are two triangles, so since there are two triangles, we have to take 180 and subtract 70.53. So 180 minus 70.53, we get 109. Oops. 109.47. We're just always going to do two decimal places. So, all right, so here are our two angle B's. The only thing we have left to do is turn them into minutes. So you're going to take the 0.53 and multiply it by 60. So 0.53 times 60 is 31.8. So that's going to be 70 degrees, 32 minutes. So there's our first one. And then here, same thing. Take the 0.47, multiply it by 60, so 0.47 times 60, and you get 28.2, which isn't going to round up, so then we have 109 degrees, 28 minutes. Okay, which is what that says. So we used the note card to figure out that there were two possible triangles, so we know we had two angle B's. Then we used our law of sines to find the first one, subtracted it from 180. Notice we subtracted it before we did the minutes, okay, because you're not going to be able to subtract minutes on your calculator. So we subtracted the decimal from 180 to get the second angle B, and then we just turned them into minutes. And then that's it. All right, let's start from scratch on this one. Angle A is 25, so it's acute. So we have to start by finding our height. So B times the sine of A. So angle B, or side B, is 10 times the sine of 25. So 10 sine 25 is 4.2. That's our height. So since it's acute, we have to compare side A, which is 15, to our height, which is 4.2. 15 is greater than our height. So this is A, this is B sine A, so we need when A is greater than B sine A. So we're here again. A is greater than B sine A, which means you have to compare A and B, which is 15 and 10. A is greater than B, so we only have one triangle. Okay? So that's good, because we don't have to do the extra steps. We just have to find one angle B because there's only one triangle. So we just set up our law of sines. So the sine of 25, so sine of angle A over side A, 15, equals the sine of B over side B, which is 10. And we only have to do one angle because there was only one triangle. So cross multiply. So we have 10 times the sine of 25 equals 15 times the sine of B. So 10 sine 25 is 4.2. Oh yeah, we already did that. 4.2 blah 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 equals 15 sine b. So then divided by 15, you get 0.28 is equal to the sine of angle B. So then you second sign your answer. So second sign, second answer. You get 16 point, we're doing 2 decimal places, so 16.36. And the only other thing we need to do is turn it into minutes. So 0.36 times 60, we don't have to subtract it from 180 because we only have one triangle. So 0.36 times 60 is 21.6. So final answer is 16 degrees and 22 minutes. Boop, boop, boop. That's it. Okay. All right, let's do this one. Same thing. A is acute. So we have to find our height. So B sine A is 7 sine 47. 7 sine 47 is 5.1. So that's our height. So we have to compare side A, which is 6, to our height. So 6, this is side A, B sine A, to 5.1. So A is greater than B sine A, so we're here again, which means we have to compare side A and side B, which is 6 to 7. So A is less than B, so we have 2 triangles. Okay? All right, 2 triangles means 2 angle Bs. How we find the first one does not change based on that, so we still have to set up our proportion. So the sine of 47 over, so the sine of angle A over side A, which is 6, equals the sine of B over 7. Cross multiply. I'm not going to show as much work on this one. So we have 7 times the sine of 47 equals 6 times the sine of B. So we do 7 sine 47 in the calculator and get 5.1 something something. Divided by 6, get 0.85. Second sine, second answer. And we round that to 2 decimal places. So that's 58.57. We have 2 possible triangles, so we need to subtract that one from 180. So 58.57. So 180 minus 58.57 is 121.43. And then we just need to turn them both into minutes. So 0.57 times 60 is 34.2. 0.43 times 60 is 25.8. So B is 58 degrees 34 minutes, and it is also 121 degrees 26 minutes. We had to have 2 because there were 2 triangles. Okay. Last one. Angle A is finally obtuse, so it's easier. So all we have to do is compare angle A, or side A and side B. So 24 is greater than 5. So it's greater, so there's 1 triangle. So you just set up your law of sines with what you have. So the sine of 95 over side A, which was 24, equals the sine of B over side B, which is 5. Cross multiply. Oh, that's ugly. Okay, so 5 times the sine of 95 equals 24 times the sine of B. So 5 sine 95, you get 4.98. Divide that by 24. You get 0.2075, second sign, second answer. And we get that B is 11.98. That's the only one we need, so we just have to take 0.98 and multiply it by 60. Because there's only one triangle, so we don't have to worry about it. Oops, 0.98 times 60. And you get 58.8. Oops. So then B is 11 degrees 59 minutes. Which is tiny, but side B is really small, so that makes sense that angle B would be really small. That's it. 6-3.